Doodle time! These may be our last doodles. I'm not sure. It might be. Alrighty. So starting with this one that says upper respiratory tract. I'll actually start over here on the left. The nasal sinuses. Obviously they're called that because they're in the nasal cavity. They are these right up above the nose. Lined with mucus, and they empty into the nasal cavity or pharynx. And if you've ever had a head cold and your sinuses get all clogged up, this is what we're talking about. This is what's causing problems. This one's right between your eyes, up by your nose. This one's kind of below your eyes. Their specific name is based on the bone they're in, so this one would be the frontal sinus because that's the frontal bone. But in general, the sinuses are just open places in the bone where air can circulate through and help it to get moist. The nose and nasal cavity, it's not shown really well in this picture, but we know if you've ever felt your nose, there's a septum. Divides the left and the right sides. Inside of the nasal cavity, you have cilia and mucus, and also hairs, but cilia are not hairs because cilia are microscopic. But all of those things help to protect the nose. So any particles that get in there, the cilia and the mucus can trap it, and the hairs can trap it so that it doesn't get down into your lungs, hopefully. They could just push it to the back of your throat and then you swallow it. A lot better for it to get destroyed in the stomach than to get stuck in your lungs. The pharynx is basically the back of the throat. This is the mouth here. It didn't copy very well. But basically your pharynx is the back of your throat and the first top part of your throat before it goes down deeper. Your larynx is where you have the vocal cords and things get divided up. That's actually coming up next. So the nasopharynx is this part that's between your nose and the beginning of your throat. That's your nasopharynx. As you can see, like, it looks like nose pharynx. It's the pharynx up there. So that is this part. Your oropharynx is the part between your mouth. So if you look in somebody's mouth, at the back of their throat, this is their oropharynx. That's what you're looking at specifically. It's also where you'd find some tonsils, which are part of the lymphatic system. The laryngopharynx. Is between the rest of the pharynx, these parts up above, the larynx, which is down below, and the esophagus, which is also below. So it's kind of like the bottom of the pharynx. It joins up with the top of the next part. And I haven't used yet. There we go. I'll pause for a couple seconds. To the larynx. So that was the nose, mouth, and pharynx with the P. Now we're going to look at the larynx with the L, which is the next part down. And then after that, we'll look at the trachea and the lungs. So we started at the top on the first page, and we're working our way down. This thyroid cartilage, it does lots of things. Like that's where your thyroid would be, right in front of that. But if you see somebody who has an Adam's apple in their throat, that's what this is. That's where you can see your thyroid cartilage. This right here. You can see here, this is the pathway down to your lungs. And this is the pathway down to your stomach. But up here, they're still kind of together. So this helps to protect these tubes. You could add that in there. The cricoid cartilage. This is what's attaching up here your larynx parts down to your trachea. And inside of here is where you'd find vocal cords. We're going to see more about those down at the bottom. That is this whole part. There's more about it down in the lower picture. And then trachea is your windpipe. We're going to see trachea several times. You can see there are cartilage rings on here. The purpose of the cartilage is to keep your throat from collapsing. So if you poke the front of your neck and you feel it kind of feels like hard and like ribbed almost, that's your trachea. That's what you're poking. The larynx parts here would be up, kind of up inside of your jaw. If you talk and touch your throat at the same time, you can figure out where your vocal cords are. So you'll feel them vibrating. It's pretty high up in there. Your trachea is this. It's the esophagus going down the stomach. So far the air came in through your nose or mouth. It hit your pharynx, which was the throat behind your nose and mouth. Then it hits your larynx, and then your trachea, and then we'll continue on after that. But first, this picture on the bottom is what it would look like if you were looking down somebody's throat. Like if you stuck a camera down somebody's throat, right down in this part, you would see this. So first, the vocal cords. It is a muscle. When I say elastic, I mean it can kind of bounce back, so it doesn't stay open or closed forever. It moves as you talk. Vocal cords. If you have a deeper voice, your vocal cords tend to be thicker. If you have a higher pitched voice, then it tends to be thinner. Oh, 1 second.
It's one that we did as a class yesterday.
We did 2 as a class.
Wait, what?
We did 2 papers as a class.
Oh. I'll probably take both of them in that case.
Okay.
Just in case.
I got extra notes.
Yeah, these are it. Okay. Thank you very much. I'll try to have these done before class today.
Okie dokie. Close the door on your way out, please.
I got you.
Apologies, 10th graders. This here is the cartilage. So this same cartilage that's up here in these ribs, this is kind of like the front. So this is the cartilage. Cartilage, and it's for protection. Same cartilage that's up here. Kind of like this front bit here. On the other side, we have the epiglottis, which actually is this big tube, and its job is to flap down and close off your trachea when you swallow something, so hopefully you don't swallow your food. The little things here, these are folds, and they also do the same thing. I'll come back to color in a second. And this actual opening in here is your trachea. So the air is actually following down through there. Let's pick some colors. It's my epiglottis. This is this part. And the folds. Where's this part? The purpose of the epiglottis and the folds is to close up over top of the trachea whenever you swallow so that your food and drink don't go down your lungs, hopefully. If it's ever accidentally gone down there, you have felt when your lungs freaked out and started coughing. Onward. So we went from, on the first page, we had the nose, mouth, and the throat, or the pharynx. On that next page, we had the larynx and the beginning of the trachea. Here we're going to continue with the trachea down into the lungs. So we're kind of, as we're going through these pages, getting deeper and deeper. Well, first, your trachea. We've already talked about trachea on the other pages, so for here we're just going to say it passes the air. All the other things about it are true on all the other pages. We're just not going to repeat ourselves a bunch of times. Here's your trachea. So it starts in kind of like the top of your neck, throat area and goes down to your lungs. So say probably about where your sternum starts-ish is about where your trachea would end. After you get down to this level, it branches into two sides, and these two smaller tubes are called bronchi. They branch toward each lung. If you're just talking about one, it's a bronchus, US. Let's make them green. Here's my bronchi. You might know the word bronchitis. Itis means inflammation of, so it means inflammation of your bronchi, or maybe your bronchioles, which is coming up next. These connect. So you can see it's kind of branching out like a tree, that it went from this one big thick part down to two smaller tubes that are called bronchi, down to even smaller tubes that are called bronchioles, and they end in these alveoli, which are tiny little bunches. Usually anything with bronch in it has something to do with lungs. So it's all of these. I'm not going to color them all because I don't want the video to be too long, but you can see what I mean. The other lung would be the same. I'm just not coloring them all, so you can save us some time. So far, everything from the nose and mouth all the way down to the bronchioles. We have not done any O2 and CO2 exchange. The gases are just moving. These are just the tubes. So it goes from the nose and mouth, pharynx, larynx, trachea, bronchi, bronchioles. When we get to the alveoli, that's when we're going to exchange the gases. All the other things are just tubes. Well, one thing about bronchioles that's different than all the other tubes is that they have muscle in them. So they can contract or expand to let air go to different parts of the lungs. And if you have asthma, this is what freaks out and causes you to not be able to breathe, your bronchioles. So anyway, your alveoli. They're a bunch of very tiny, so tiny, like microscopic tiny. If you cut open somebody's lung, you wouldn't see the alveoli. You'd have to put it under a microscope. And around them are capillaries. So before I finish filling in this box, we'd have the heart right about in here. Then the pulmonary artery would come out, and it would go both left and right. So there's a big artery here that goes along the bronchi, and then it gets smaller and smaller and smaller and smaller and smaller as it branches out. And one time it gets around these alveoli, it's capillary size. So very thin, like 1 cell thick wall, super, super teeny. And this is where oxygen and CO2 are exchanged, which is what it's showing in this picture. The arrows are kind of hard to see, so I'll come in and color those in a second. But the alveoli are all these little things that kind of look like flowers. Those are all alveoli. You can color in more if you'd like. So CO2 comes out and goes into the alveoli. O2 goes into the blood. The arrows are on that paper, just kind of hard to see. So the little capillaries come around. There's a little capillary around each one of these little bunches. The deoxygenated or vein blood comes in here, passes out its carbon dioxide, gets more oxygen, and then goes back toward the heart. And it kind of goes opposite, that these little tiny capillaries will build up into bigger and bigger and bigger vessels until eventually you get to that big chunky pulmonary vein coming back toward the heart. I'll leave this one for a couple seconds, and we'll go on to our last one. Long pressure. So what this graph is if you were just breathing into a tube, if you have asthma, you might have had to do that at some point. This shows you your breathing pattern. So it's kind of like you breathe into a computer and it prints out a graph of your breathing. All these going up parts of the wave are times you would breathe in, and all the going down are times you'd breathe out. There's one of these I'm not really going to define because it's this FRC one. I'm going to kind of skip that. So for those of you paying attention, you might miss that. This over here corresponds with different parts of the graph, and some of them are also defined and written down here. So I'm going to kind of be jumping around a little bit on this paper. This box right here is your whole inspiratory capacity, or how much you could possibly breathe in. Okay. I'm actually going to write it sideways because that's a big word. Or how much you could totally breathe in. So it's all these up waves all together. This one is technically how much you can breathe out, but that's where they had FRC, which I don't know why they call it functional residual capacity, but I'm just going to say that's how much you could possibly breathe out. I'm not coloring anything with those because they're not really listed over here. But all the ups are all the total breathing in, all the downs are the total breathing out. Okay. I'm actually going to jump to this one. It says VT and TV down. I'm not sure why they flipped it. I borrowed this off of somebody else on the internet. But I will color code it. Tidal volume when you're just sitting there chilling, not doing much, that's the tidal volume. So it's the amount that you normally breathe in and out. It's like that's this middle wave. If you took one big giant breath in, the biggest breath in you could possibly take, that would be inspiratory reserve volume. So it's kind of beyond what you would just normally breathe and normal things. If you took a huge breath in, and that one is here. I'm just writing IRV because I couldn't possibly fit that in there. Oh, it's blue. It's really the amount you could additionally inhale. If you just breathe in, as much breathing in as you could possibly breathe in. The other one, the expiratory reserve volume, is how much you could possibly breathe out. So beyond, if you really pushed all the air out of your lungs, what that would look like. I haven't used orange yet. Let's do that. Residual volume is both of these boxes here. These squares over here are other different ways to represent it besides this graph. So like you could just represent it by some of these chunks. That's why it's in multiple places. I haven't used yellow yet. Let's use yellow. There's always at least a little bit of air that never makes it down to the alveoli to actually be exchanged with your blood. It's only a small amount of it, so that's kind of what the residual volume. You kind of just breathe it back out. So it's just a little bit of all the total air you breathe. This last bar over here is the total lung capacity. So there's always a little bit that makes it into your lungs, but you don't actually exhale it, or it might be some of like the nitrogen and stuff that we don't use anyway. We just breathe it back out. Total lung capacity. It's just what it says down here. So I'm going to go over here. Or TLC. What haven't I used yet? What green? Not that green because it's not working. There we go. Total lung capacity is not on here because it's basically like this whole thing, but it is down here. If you are a male-bodied adult, your total capacity is about 4.6 liters, like the maximum amount you could possibly breathe in. And if you're an adult female, it's about 3.4 liters. Notice it says on average, so if you're a super endurance athlete, then maybe yours is higher than average. If you're a very small person, then maybe it's lower than average, or a very large person, maybe it's bigger than average. Like super, super tall guys might have more than this. Those itty bitty small girls might have less than this. So this is kind of on average. This total lung capacity would be all these put together. Last one is vital capacity. It defines it here, amount that can be expired after maximum expiration. So it's kind of this woo wave, this really big wave, the really big inhale and the really big exhale all together is the vital capacity. Or VC. I'm going to make it purple. Vital capacity is about 80% of your total lung capacity. So the amount you could really breathe in and then breathe out is about 80% of this. The rest is the residual volume that doesn't really go anywhere. Okay, hopefully that makes sense. I'm going to end this very long video. Thanks for sticking with me. If you got any questions, comments, concerns, epiphanies, etc., let me know.